introduction to exercise 3C on applying Pythagoras theorem, page 158 of your textbook. So we've learned about Pythagoras theorem before. We already know that it's a squared plus b squared equals c squared. I'm just going to write the top over here so that we remember it. Okay? You should have that in your notes previously. Now the whole idea, we've talked about it, is that Pythagoras theorem we know is a real thing and we know how to use it, but how do we apply it? Okay? So for this, we're going to be following a set of rules where we can use Pythagoras theorem to make it a bit easier to understand, even when we're presented with information in a worded form. Okay? So the first example that I'm asking us to do is look at this do now question where we're presented with a circle and a square on the inside. The first step says if a circle has a diameter of 2 centimeters, what's the diameter? That would be the circumference. So the diameter is it's kind of like the width of a circle. So for example, if that's a circle, that would be the diameter. What's the name for the one that's half the diameter? Radius, good. Okay, so the diameter of the circle is 2 centimeters. Where can we draw the line, or where can we draw the diameter to form a right angle triangle? Well, it makes sense that we can just draw a line between here, right? That's 2 centimeters. Now my question is, if that's 2 centimeters, is this also 2 centimeters? It might be, it might not be, right? Well, we know that this forms a right angle triangle, doesn't it? Apologies for the awful drawing, but that's a right angle triangle where that's our right angle. In this case, the purple 2 centimeter line is our hypotenuse, isn't it? Yeah? And the hypotenuse is always the longest side. So in this case, these lines here are most likely going to be less than 2 centimeters. And we can use Pythagoras theorem to figure that out. Now we know the rule is a squared plus b squared equals c squared. I'm going to give a letter, just for argument's sakes, to call these two sides. Brody, give me a letter. X. So let's call this x. If that's x, what's this one going to be? Y. It could be y, but they're the same, aren't they? So let's skip a step. Let's just call them both x. Yeah? Now using Pythagoras theorem, I know that a squared plus b squared equals c squared. So a squared, I'm not going to write a, just like we did last lesson. I'm going to replace it with what I'm calling this. In this case, x. So x squared plus, what's b in this case? X. Also x, good. So x squared equals c squared. I'm going to skip a step. I'm not going to write 2 squared. I'm just going to straight up write 4. Now, we can do what we did last lesson again and say, well, x squared plus x squared is 2x squared, which still equals to 4. And then I could divide both sides by 2, end up with x squared equals to 2. Do I leave it there? Am I done? Oscar, besides the tone of my voice, why should we not stop there? What are we looking for? Each side. Good, and each side is just x, isn't it? Not x squared, but just x. So what do I do to get from x squared to x? What's that process called? The opposite of squared. I know you know this. What's this thing? What's that thing? Square root, thank you very much. To do the opposite of square, we square root. Yeah? I know it's a library. You don't need to be quiet in this circumstance. You're allowed to talk to me, okay? So square root of 2 in that circumstance. So that's doing the same thing we did last lesson, just with words. Okay? It's our job. The difficult part isn't to do that, what we did last lesson, but the difficult part is to try and interpret a worded question so we know where that comes from. Now, you've already written the next 4 steps, but I'm going to read them out to you anyway. The 4 steps say, when applying Pythagoras theorem, the first thing you should do is identify and draw the relevant right angle triangle. It makes sense. If you're doing Pythagoras theorem, you look for a triangle. It has to be right angled though. You label the sides with the lengths or the pronumerals. What is pronumerals again? What does that mean in everyday language? It's not the numbers, it's the letters. Yeah, it's just fancy math notation for letters. 3, you solve for the unknown, and 4, you solve it, and then you answer in words, okay? So, let's look at this example here. 2 poles are located 40 meters apart, and a rope links the top of the 2 poles. Now, for me, my first step is typically to just draw the picture out. You're not going to lose marks if your picture looks really bad, by the way. I'm also not going to give you marks if the picture looks picture perfect, but it's still going to help you out, okay? So I'm going to draw 2 poles. They're located 40 meters apart, so I'm going to go ahead and draw this out. You don't have to copy down the actual question, but please copy down the diagram so you can still follow along with the steps. So those are the 2 poles, and it says that it's 40 meters apart, so I'm going to go ahead and draw a 40 meters here. In the first sentence, I should also add something I haven't added to my diagram. What should I be adding? Hayden's that hand up? No? So have I added my 2 poles? Yep. Have I added in that they're located 40 meters apart? Yep. Did I add in there's a rope linking to the top of the 2 parts? No, I should add that in as well, shouldn't I? So I'm going to add that into my drawing. Now, it says, find the length of the rope if the poles are 15 meters and 21 meters in height. Now, obviously, we know one's shorter than the other, so I'm going to just go ahead and label this as 15 meters and this one as 21 meters. What are we looking for? What's the question asking us? Come on, what are we looking for? It says, what are we finding? Yes, Caitlin. Thank you very much for finding the length of the rope. Just to make it easy, I'm going to call it R. Now here's the tricky part. We've drawn this diagram. I think as a class we all agree that this diagram is accurate to what the question's asking. Or presenting, rather. To me, the shape I'm seeing is this. Does Pythagoras' theorem work in that case? Not really. So we have to find a right angle triangle. Where could I find a right angle triangle? Well, I could just cut off most of it and just focus on this, couldn't I? Is that a right angle triangle? It is. What is the value of, let's say, this side? What's the height of that? I know this is 15. I know the taller one is 21 meters. So what's the height of this difference? 6 meters, thank you very much. So I know that this is 6 meters. And I also know the base. The base is 40 because we wrote that from earlier. Now, for me, you don't have to do this part, but I like to just draw the triangle out on the side just to make it a bit easier for me to see. I'm going to say that this one is 40 meters, this one is 6 meters, and this one is R. Is this question looking a lot easier to do now? Yeah. So now, all I use is Pythagoras' theorem. I'm going to just casually assign A, B, and C just to make my life easier. I'm going to say A is, Brody, which one do you want to call A? 40 or 6?
What?
Which one do you want to call A? 40? Okay, let's call A 40. We'll call B 6. And C, what are we calling C? Thank you very much. So, we have these values here. All I'm going to do is put them into my formula. I know A squared, so that's 40 squared, plus B squared, which is 6 squared, equals to C squared. In this case, of course, that's going to be R squared instead. Then I get my calculator out, which I'm assuming everyone here has. And I go, what, 40 times 40? You can put that in the calculator if you'd like. 1,600. Plus, I know 6 times 6 is 36. Equals to R squared, which I'm going to just quickly add them together. And that gives me 1636. Oscar, I'm going to ask you the same question. Am I happy with that? Done. R squared equals 1,636. No, because you need to do the square root. Thank you very much. So I'm going to write R equals to the square root of 1636. Now this is where most students would accidentally lose a mark. Can anyone tell me why they would lose a mark? We found r. We're not looking for r squared, we're looking for r. We found r. Why would students still lose a mark if we left the answer like this? You're right, but how do you know that? How do you know you need to find that number? Is there something in the question that tells you to do that? Thank you very much. It specifically says, give your answer correct to 2 decimal places. Please don't just finish the question and say, all right, I'm done, clap your hands and walk off. Make sure you just double check that you've answered what the question wants. It says it wants a square root of 1636 to 2 decimal places. I'm going to go 163. Sorry, can you say that one more time for me? 40.44. I'll take your word for it. What's the next digit in the decimals? So if it's 40.447, we round up. Thank you very much. And becomes 40.45. Now we're done. I'm missing 2 things. What am I missing? What's one of them? Are we feeling a bit tired since it's after lunch? What are we missing? 40.45 what? Thank you very much. Meters, good. And of course, because it's a worded problem, you should be presenting your answer in words. So I would write here, the rope is 40.45 meters long. Done. That's it. Any questions about that? It's a bit longer of a step, right? But all we need to do is identify the triangle. Okay.